All right, let's get right into it. For a while now, we've gotten pretty used to AI as these incredibly smart chatbots. They're powerful, they're knowledgeable, but at the end of the day, they're mostly passive. But the next leap forward? Well, it's something else entirely. We're moving beyond just knowing things to actually doing things. And this, right here, is the fundamental shift. It's the core idea. AI is evolving from just a brain that knows, think of it like a super intelligent encyclopedia, into a being that acts. It's really the difference between having a library and having a personal librarian who can actually leave the building, go run errands, and complete entire projects for you. This change from a passive brain to an active agent is a massive, massive deal for what AI can do. So to make this crystal clear, let's break it down. A standard large language model, an LLM, is that brilliant librarian. You ask a question, it gives you an amazing answer based on the books it has right there. It's a smart but pretty static one-and-done interaction. An AI agent, though, that's more like a personal research assistant. It doesn't just answer your question. It can leave the library, fire up a web browser, run some code, manage a complex multi-step project, and, this is the key, it can actually learn from what it does. But this incredible new power comes with a pretty big hidden catch. And that catch is the high cost of action. Yep, the very thing that makes these agents so powerful also makes them incredibly expensive and slow to run in the real world. Let's dig into why that is. Okay, so every single time an agent needs to do something, it goes through this thinking loop. First, it has to check its memory. What have I done so far? What did I learn? Then it has to come up with a plan. What's the logical next step? After that, it uses a tool, it performs an action in the world, and finally it looks at what happened, processes that result, learns from it, and then starts the whole loop all over again for the very next step. And each and every one of these steps costs time and money. And that's where the real problem lies. See, it's not a one-time cost, because this loop is recursive. The costs just keep piling up. The output from one cycle becomes the brand new input for the next one, creating this massive snowball effect. We're talking more tokens, which are just the little pieces of words the AI chews on, which leads to longer wait times and a much, much higher bill for all that computation. It makes running these agents at any real scale almost impossible right now. So the key takeaway from the researchers is this: making an efficient agent isn't about just making the AI model smaller. No, it's about designing a whole system that is perfectly optimized to get the job done right while using the absolute minimum amount of resources. It's a really delicate balancing act between raw power and real-world price. So how in the world do you achieve that balance? Well, the first big area where people are innovating is memory. The challenge is huge. How do you give an agent a useful memory of what it's done without forcing it to reread its entire life story every single time it needs to think? So there are two main ways researchers are approaching this. First, you've got working memory. This is all the information the agent has right there in its immediate context. It's kind of like the thoughts that are in your own head right now. It's super fast and easy to access, but it's also really limited in size. Then you have external memory. This is info that's stored outside the agent, almost like a personal library it can search whenever it needs to. It's practically unlimited, but you guessed it, searching that library takes extra time and effort. So, how do you organize that external library to make it fast? Well, there are a few really clever approaches. You've got item-based memory, which is like a simple diary, just logging each experience one by one. Then there's graph-based memory, which is more like a mind map, connecting ideas to show how they all relate to each other. And then you have hierarchical memory, which acts just like a book's table of contents, letting the agent jump right to the fine-grained detail it needs without having to read the whole chapter. So it really all boils down to this classic strategic trade-off. Working memory is blazing fast, but it's small, and important details can easily get lost in the noise. External memory can store everything, forever, but pulling information from it adds delays and makes the whole system more complex. The smartest agent designs are probably going to use a clever mix of both. But look, a smart memory is a huge piece of the puzzle, but it's only half the battle. To be truly efficient, an agent's actions and its plans also have to be super decisive. This really means improving how they use their tools and how they think about the future. The process of using a tool might look simple on the surface, but each step has these hidden costs. First, the agent has to select the perfect tool from maybe thousands of options. Then it has to figure out exactly how to use that tool with the right inputs. And finally, it has to reason about what the tool's output actually means and how that changes its overall plan.
And this really splits the challenge of planning into two different problems. For a single agent working alone, the goal is to make its own thinking process more efficient. Cutting down on wasted steps by breaking tasks down in a smarter way. But when you have a whole team of agents working together, the challenge completely shifts. Now it's all about optimizing their communication. You've got to reduce the chit-chat and make sure they can share what they know without getting in each other's way. When you take a step back, all of this research into memory, into tools, into planning, it's all part of a much larger quest. It's about way more than just cutting costs. It's about building a fundamentally smarter and more capable kind of artificial intelligence.
Because at the end of the day, the goal is to find that perfect sweet spot, what researchers call the Pareto frontier. Just think of it like a menu with all the best possible deals where you just can't get any more performance without paying a higher price. The goal is to find that perfect item on the menu, getting the absolute maximum effectiveness for a given cost. It's about building agents that aren't just powerful enough to solve real problems, but also efficient enough to be used everywhere, by everyone. Which, of course, leaves us with a final, really fascinating question to think about. Once these agents are both powerful and affordable, what are we going to ask them to do? The possibilities are just staggering, from accelerating scientific discovery to personal assistants that can manage our entire digital lives. What problems will we finally be able to solve?